When installing a battery-operated standby sump pump, especially concerning the extension of the connection distance between the 12 volts direct current battery and charger and the pump or float switch, safety is paramount. Given the proximity to a gas water heater, it's crucial to address potential ignition risks. The primary concern is maintaining a safe distance between the battery considered a potential ignition source and the gas water heater. Manufacturers often recommend a safe distance, though specific measurements may vary and legal reasons may restrict explicit declarations. The recommendation to move the battery as far away from the water heater as possible is a general guideline. Raising the battery above the flame height of the water heater is another suggested precaution, aiming to minimize the risk of flammable vapors coming into contact with any potential ignition source from the battery. Considering wire size, the existing setup uses 16 American wire gauge wire. When extending the distance, a crucial consideration is whether to increase the wire gauge. Using a larger wire gauge, meaning a wire with a lower American wire gauge number, will reduce heat buildup during operation. This is because a larger gauge wire has lower resistance, allowing for more efficient current flow and reducing the risk of overheating, especially over extended distances. When selecting wire, several factors come into play. Firstly, the wire must be adequately insulated to prevent electrical shorts and ensure safety. If the wire will be run through joists in the basement, it's preferable to use wire that is not only insulated but also rated for underground use. This provides an extra layer of protection against moisture and potential damage. Finding a Romex equivalent in smaller gauges like 16 American wire gauge can be challenging, as Romex typically refers to non-metallic sheath cable used for interior wiring. However, the goal is to find a cable that offers similar protection and insulation. A suitable alternative is to seek a non-metallic cable with 16 American wire gauge or thicker wires. Examples of such cables include type UFB, which stands for Underground Feeder and Branch Circuit Cable, or RHH-RHW-2 cable, which are cross-linked polyethylene insulated wires with heat and water resistance. These cables are designed for direct burial and offer robust protection against environmental factors. If the cable will be run underground, it is essential to ensure that it is rated for direct burial. This means that the cable is specifically designed to withstand the conditions of being buried in the earth, including moisture, temperature fluctuations, and physical stress. Proper installation is critical for ensuring the safety and reliability of the sump pump system. Firstly, install the battery in a separate location as far away from the water heater as feasible. This minimizes the risk of ignition in case of any unforeseen circumstances. Secondly, run the wires through conduits or raceways to protect them from physical damage. Conduit provides a robust barrier against impacts, moisture, and rodents, ensuring the longevity and integrity of the wiring. Thirdly, make sure that all electrical connections are secure and watertight. This prevents corrosion, which can lead to increased resistance and heat buildup. Watertight connections also minimize the risk of electrical shorts and ensure reliable operation of the sump pump. Finally, ground the sump pump and any metal components to prevent electrical hazards. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or ground fault circuit interrupter and preventing electric shock. Here are some additional tips to keep in mind. Firstly, consult with a licensed electrician for professional advice and installation. A qualified electrician can assess the specific conditions of the installation and provide recommendations tailored to the situation, ensuring compliance with local electrical codes and regulations. Secondly, follow all manufacturer's instructions carefully. The manufacturer's instructions provide detailed guidance on the proper installation, operation, and maintenance of the sump pump system, ensuring optimal performance and longevity. Thirdly, test the sump pump system regularly to ensure that it is functioning properly. This includes checking the battery charge, the operation of the float switch, and the flow rate of the pump. Regular testing can identify potential issues early on, allowing for timely repairs and preventing costly damage. Finally, keep the battery and charger in good condition to ensure reliable backup power. This includes cleaning the battery terminals, checking the electrolyte level, and replacing the battery as needed. A well-maintained battery is essential for providing reliable backup power during power outages. Remember, dealing with electrical systems can be dangerous, and it's always best to consult with a qualified electrician to ensure that the installation is done safely and correctly. By following these guidelines, you can extend the connection distance of your battery-operated sump pump while minimizing the risk of electrical hazards and ensuring the reliable operation of your backup system. When selecting wire for extending the connection between the battery and the sump pump, consider the following factors. Firstly, the ampacity of the wire needs to be sufficient to handle the current draw of the pump. This is determined by the wire gauge and the type of insulation. Consult a table, such as those found in the National Electrical Code, or NEC, to determine the appropriate wire gauge for the expected current and the length of the run. Secondly, the voltage drop over the extended distance needs to be considered. Voltage drop occurs due to the resistance of the wire, and excessive voltage drop can reduce the performance of the pump. Using a larger gauge wire will reduce voltage drop. There are online voltage drop calculators that can help determine the appropriate wire gauge for a given distance and current. Thirdly, the type of insulation needs to be appropriate for the environment. If the wire will be exposed to moisture, chemicals, or extreme temperatures, it needs to have appropriate insulation to withstand these conditions. USB cable, for example, is suitable for direct burial and wet locations. Fourthly, the wire needs to be protected from physical damage. Running the wire through conduit, such as PVC or metal conduit, will provide protection from impacts, abrasion, and other hazards. Additionally, the conduit needs to be properly supported and secured. Fifthly, all electrical connections need to be made in a secure and weatherproof manner. Use appropriate connectors and terminals to ensure a reliable connection. Seal the connections with silicone sealant or other waterproof material to prevent corrosion. When placing the battery, consider the following. Firstly, the battery should be located in a well-ventilated area to prevent the buildup of explosive gases. Batteries can release hydrogen gas during charging, which is flammable. Secondly, the battery should be protected from extreme temperatures. High temperatures can shorten the lifespan of the battery, while low temperatures can reduce its capacity. Thirdly, the battery should be placed on a stable and level surface to prevent it from tipping over. Fourthly, the battery should be readily accessible for maintenance and replacement. Avoid placing the battery in a hard-to-reach location. Fifthly, the battery should be protected from physical damage. Consider placing the battery in a battery box or other enclosure to protect it from impacts and other hazards. When grounding the sump pump, follow these guidelines. Firstly, use a grounding conductor of the appropriate size. The grounding conductor should be sized according to the size of the circuit conductors. Secondly, connect the grounding conductor to a grounding electrode system, such as a ground rod or a metal water pipe. Thirdly, make sure that the grounding connections are secure and corrosion resistant. Use appropriate connectors and terminals, and protect the connections with anti-corrosion compound. Fourthly, test the grounding system to ensure that it is effective. Use a ground resistance meter to measure the resistance of the grounding system. The resistance should be low enough to provide a safe path for fault current to flow back to the source. Finally, consult with a qualified electrician to ensure that the grounding system is installed correctly and meets all applicable codes and regulations. Remember to always disconnect power before working on electrical equipment. Use appropriate personal protective equipment, such as gloves and safety glasses. Work in a well-lit area and avoid distractions. If you are not comfortable working with electrical equipment, hire a qualified electrician to do your work. The NEC provides detailed requirements for the installation of electrical equipment, including sump pumps and battery backup systems. Consult the NEC for specific requirements related to wire size, overcurrent protection, grounding, and other aspects of the installation. Some relevant NEC sections include Article 300 for wiring methods, Article 310 for conductors for general wiring, Article 430 for motors, motor circuits and controllers, Article 500 through 516 for hazardous locations, and Article 700 through 702 for emergency systems. The NEC is updated every 3 years, so make sure that you are using the latest edition. The authority having jurisdiction, or OJ, is responsible for enforcing the NEC and other applicable codes and regulations. The AHA may be a local building inspector, a fire marshal, or other official. Consult with the AHA to determine the specific requirements for your installation. The AHA may require permits, inspections, and other documentation to ensure compliance with applicable codes and regulations. Obtaining the necessary permits and approvals before starting work can help avoid costly delays and penalties. Additionally, it is crucial to ensure that the chosen location for the backup system and wiring complies with any local ordinances or regulations regarding flammable materials and electrical installations. These ordinances may dictate specific distances from gas appliances or require additional safety measures. In addition to adhering to safety codes and regulations, implementing preventative maintenance practices can significantly extend the life and reliability of your battery backup sump pump system. Regularly inspect the battery terminals for corrosion and clean them as needed. Check the battery's charge level and ensure that the charger is functioning correctly. Periodically test the sump pump's operation by manually activating the float switch. This helps to verify that the pump is working and that the discharge line is clear. Furthermore, consider installing a high water alarm. This alarm will alert you if the sump pump fails to keep up with the water inflow, providing an early warning of a potential flood. The alarm can be wired to an audible alarm or connected to a remote monitoring system. Another important consideration is the lifespan of the battery. Batteries have a limited lifespan and will eventually need to be replaced. The lifespan of a battery depends on several factors, including the type of battery, the frequency of use, and the charging and discharging cycles. Check the battery's date code to determine its age. A typical battery for a sump pump backup system may last for 3 to 5 years. Be prepared to replace the battery when it reaches the end of its lifespan. When replacing the battery, choose a battery that is specifically designed for sump pump backup systems. These batteries are typically deep cycle batteries, which are designed to withstand repeated charging and discharging cycles. They also have a higher capacity than standard car batteries, allowing them to power the sump pump for a longer period of time. In summary, extending the connection distance of a battery-operated sump pump requires careful consideration of wire size, insulation, voltage drop, and safety precautions. Placing the battery in a safe location and protecting the wiring from damage are essential for preventing electrical hazards. Regular maintenance and testing can ensure the reliable operation of the backup system. Consulting with a qualified electrician and adhering to applicable codes and regulations will help ensure a safe and compliant installation. By following these guidelines, you can protect your home from flooding and ensure the safety of your family. Remember to prioritize safety and always seek professional assistance when needed.